Hello everyone. In recent years, scientific advancements have brought humanity closer to a discovery that has long eluded us: the potential existence of life beyond Earth, as we wait for concrete evidence that could confirm or deny this possibility. It's important to think deeply about what such a discovery could mean for us, not only in terms of understanding the universe, but also for confronting our own potential extinction. The question of life elsewhere could reveal profound truths about the universe and equally about our own fragile existence. Before we dive deeper into the implications of these groundbreaking discoveries, I want to share a quick update. We need your support to help our channel reach more viewers. The algorithm is limiting the visibility of our episodes to subscribers, and we can fight this by simply liking the video and leaving a comment. This small action signals to the algorithm to share our videos with a wider community. If you haven't done so already, make sure to subscribe and hit the bell so you never miss an episode. On another note, we're thrilled to announce the launch of our very first product, a premium backpack we call the Black Hole Bag. This 28-liter bag is not just functional. It comes with a padded laptop sleeve, multiple compartments to keep your belongings organized, and a roll-top design. It's made from recycled polyester, making it both sustainable and incredibly durable. Like a black hole, nothing escapes the secure design of this bag. And for the next 48 hours, we're offering a 10% discount. So be sure to check out the link in the description to grab yours while the offer lasts. Billions of years ago, two planets, one smaller and one larger, spun around a young star, their surfaces hosting complex chemical reactions. These reactions began to form simple life forms, small yet extraordinary in their ability to evolve and adapt. On the smaller of these worlds, one life form learned to extract energy from the environment in a creative way by reducing iron compounds into more stable forms. It thrived in mineral-rich areas, spreading outward in what could be called a metabolic shock wave, leaving patterns of vivianite in damp river deltas. Who knows how much further this life form could have evolved if given more time, or how much more advanced it could have become. Unfortunately, it didn't have that time. The planet was small, and its molten core cooled quickly, locking in its internal heat. The once active magnetic field vanished, and the planet's atmosphere was stripped away by the relentless solar wind, leaving the surface exposed to the cold void of space. With no atmosphere, the planet froze. The larger planet, however, fared better, at least for a while. It held on to its internal heat longer, preserving its magnetism, atmosphere, and water, as well as the carbon cycle. This allowed life to thrive on its surface, and over time, it gave rise to more complex life forms, capable of expanding their reach and exploring their surroundings. Some of these life forms became incredibly ingenious, finding ways to travel between the worlds, or at least sending their machines across vast distances. Over 3 billion years later, the remnants of these two neighboring planets met. A robot from one touched a fossil from the other. In that moment, the life form, now represented by the robot, realized two things. The first was that it wasn't alone in the universe, and the second, more unsettling realization, was that its own doom might be closer than it had imagined. If you haven't guessed already, the smaller planet is Mars, and the larger one is Earth. The robot in question is NASA's Perseverance rover, which, after landing on Mars in February 2021, explored the Jezero crater, a location selected for its potential to reveal evidence of past life. The crater, once home to an ancient lake with dry riverbeds flowing in and out, holds the key to understanding whether Mars ever supported life. Perseverance's journey took it to the Neurat Vallis region, a part of the ancient river delta that once fed the lake. There, the rover set its sights on an intriguing outcrop known as the Bright Angelon unusual iron-rich sedimentary rock that had washed into the region billions of years ago. It was here, amidst this ancient riverbed, that Perseverance uncovered a series of small millimeter-scale spots and rings that looked remarkably similar to patterns created by Earth's microbial life. These patterns, which have been dubbed poppy seeds and leopard spots, sparked immediate interest because they seemed to indicate a process that, on Earth, would be associated with microbial activity. To investigate these spots further, Perseverance drilled samples from the surface, performing a range of tests including Raman spectroscopy and reflectance analysis, and also used X-ray fluorescence to examine the mineral composition. It then sent this data back to Earth, where scientists at NASA carefully analyzed the results over several months. What they discovered was fascinating. The spots appeared to be made of iron phosphate, while the pale centers of the rings contained iron sulfide, a compound known as vivianite. Furthermore, the data showed a strong association with organic molecules, though it's important to note that in this case, organic doesn't necessarily imply life, but rather carbon-based molecules that life often uses. The analysis suggested a chemical process involving oxidation of organic molecules, which then reduced the iron in the sediment into iron phosphate and eventually into iron sulfides. This process is strikingly similar to the way certain microbes on Earth extract energy from minerals, growing and expanding in the process, often creating similar structural patterns. While alternative explanations do exist, such as high heat or acidic environments being responsible for these reactions, there is no clear evidence of either in the ancient Martian environment. There's also no indication of potential geothermal sulfur sources that could account for the presence of the sulfide compounds. Thus, the evidence seems to point toward a microbial-like process. However, this discovery doesn't immediately confirm the presence of ancient life on Mars. We've seen similar headlines in the past, where scientists found signs of possible life, only to later discover abiotic processes that could explain the same phenomena. Yet, what makes this discovery different is the unique nature of these findings. Previous claims of potential life markers were more tentative or had clear abiotic explanations. In contrast, the evidence in this case presents a more compelling argument, albeit one that still requires further study to verify. Looking back at other potential life signatures found in the past, there have been similar claims made. For example, over a year ago, NASA's James Webb Space Telescope, JWST, reported detecting dimethyl sulfide in the atmosphere of a planet orbiting a red dwarf star, 124 light-years away. Dimethyl sulfide is a molecule that is a major byproduct of microbial metabolism here on Earth. There's no known abiotic mechanism that could produce it in the quantities detected by the JWST. However, despite the initial excitement, further observations have yet to confirm this detection, and it remains a tentative result. It's not the first time we've encountered such uncertainty. Back in 2020, a team of astronomers detected phosphine in the atmosphere of Venus, another possible sign of microbial life. Phosphine is another byproduct of microbial metabolism, and its discovery sparked a flurry of excitement. The idea was that it might be produced by microbial colonies living in the clouds of Venus, possibly in regions with conditions that are more Earth-like. However, the detection has yet to be definitively confirmed, and there are potential abiotic processes that could explain the presence of phosphine in Venus's atmosphere. Even more speculative were the reports of peculiar mineral formations in a Mars meteorite that fell to Earth, which some scientists believed might be fossilized microbes, while the mineral formations showed intriguing cylindrical shapes that resembled fossils. Other scientists pointed out that abiotic processes could also account for the structures. As with the other findings, there was uncertainty surrounding the claim, and a degree of skepticism pervaded the scientific community. The key takeaway from all of these past discoveries is that while the idea of discovering extraterrestrial life is exciting, it's crucial to remain cautious and to consider all possible explanations. Yet the findings from Mars seem to be different. The patterns discovered in the Jezero crater don't yet have a clear abiotic explanation, although alternative hypotheses still exist. The absence of certain conditions, like extreme heat or acidity, strengthens the possibility that these markings could indeed be the result of microbial activity, whether from Earth-like life or something distinctly Martian. Despite this intriguing evidence, we still cannot conclusively state whether these findings on Mars definitively point to ancient life. The analysis is still ongoing, and more data is required to confirm the findings. What we can say, however, is that the evidence gathered so far is compelling enough to suggest that the possibility of past life on Mars is more than just a fleeting hypothesis. The patterns observed by Perseverance are unique, and their similarity to the metabolic rings created by Earth's microbes is too striking to dismiss outright. This discovery has profound implications, not only for the search for life beyond Earth, but for our understanding of life itself. If life did emerge on Mars, it would imply that the conditions necessary for life to take hold are not as rare or specific as we once thought. It would suggest that life, or at least the building blocks of life, could emerge in other parts of the universe more readily than we've previously assumed. The possibility that life existed on Mars raises a key question. If life was able to form there, why didn't it survive? Why did Mars, once a wet and warm world, become the barren, inhospitable planet we see today? This leads us to another important consideration: our own future. If life can emerge and then be wiped out on a planet like Mars, what's to say that the same won't happen to Earth? If Mars's history serves as a cautionary tale, we may need to reconsider our assumptions about humanity's longevity. It's all too easy to assume that we are immune to the dangers that once befell Mars. But the truth is that our world is far more vulnerable than we often acknowledge. While we continue to explore the stars and seek signs of life on distant planets, we must also turn our gaze inward and ask ourselves what steps we need to take to ensure our own survival. The possibility that life on Mars was snuffed out long before it could evolve into something more complex suggests that there are forces beyond our control that could similarly impact Earth's future. When we look at Earth's history, we can see how fragile life can be. Over millions of years, our planet has gone through catastrophic events: asteroid impacts, volcanic eruptions, ice ages, and more that have threatened life on a global scale. But humanity has evolved with a remarkable ability to adapt and overcome these challenges. We've built civilizations, developed advanced technologies, and learned how to manipulate our environment in ways that have allowed us to thrive. However, the history of Mars serves as a reminder that even the most seemingly stable environments can change in an instant. The idea that life could have once thrived on Mars, only to be extinguished, should serve as a wake-up call for us. It underscores the precariousness of life in the universe and the delicate balance required for a planet to sustain it. As we search for life on other planets, we are also searching for answers about our own fate. Could humanity's eventual downfall be linked to the same forces that doomed Mars? Are we on a path that leads to the same fate, one where our once vibrant planet becomes a cold, desolate world? The discovery of potential ancient life on Mars also forces us to confront the concept of the Great Filter. This is the idea that there are steps in the development of intelligent life that are so incredibly difficult to pass through that most civilizations never make it. If life is common in the universe, why haven't we encountered advanced alien civilizations? The absence of detectable extraterrestrial life, despite the vastness of the universe, suggests that something prevents civilizations from advancing beyond a certain point. Is the Great Filter behind us, meaning that humanity is one of the few to survive? Or is it ahead of us, suggesting that our most challenging days lie ahead? If the Great Filter is ahead of us, it implies that humanity may face existential threats that we are not yet fully aware of, or that we are currently underestimating. The idea that we are just one of the few civilizations to survive past the critical junctures in the development of intelligent life is both humbling and terrifying. If we are indeed fortunate to have passed the hardest parts of the Great Filter, could it be that the challenges ahead of us, like the rapid development of technology, environmental degradation, or even the potential for self-destruction are real hurdles? This brings us back to Mars and the question of whether life ever existed there. The discovery of possible ancient life on Mars would force us to reconsider what we know about the conditions that allow life to thrive. Mars and Earth share a similar history. Both once had the right conditions for life to emerge. The difference is that Earth has managed to retain those conditions while Mars did not. If life could emerge on Mars, even briefly, it suggests that the right conditions for life might not be as rare or as specific as we once thought. The implications for humanity are profound. If life could exist on Mars, then it stands to reason that there may be many more planets out there, even in our own solar system, that have the potential to host life, perhaps in forms that are very different from what we understand. It opens up the possibility that the universe may be teeming with life, waiting for us to find it. At the same time, this raises the uncomfortable question of whether we, as humans, are prepared to deal with the implications of encountering extraterrestrial life, or whether we are doomed to repeat the same mistakes as the civilizations that once inhabited Mars. As we continue our search for life beyond Earth, the possibility that Mars once hosted life, if life did exist on Mars, It would suggest that the emergence of life is not a singular event that only happened here on Earth, but rather a process that might be more common than we previously thought. It challenges our understanding of how life begins and evolves, and it makes the universe feel less like a barren, lifeless expanse, and more like a place filled with untapped potential. The idea that life could exist or could have existed on Mars also brings up the issue of our own survival. As we look to explore and colonize other planets, particularly Mars, we must ask ourselves, what are we really doing? Are we truly prepared for the challenges that come with establishing life on a hostile, uninhabitable world? The dangers of colonizing a planet like Mars are numerous. From radiation exposure to extreme temperatures, the risks to human life are significant. And yet, humanity seems intent on pushing forward, driven by the desire to explore and expand beyond the confines of Earth. But there's an important question to consider. If we do make it to Mars and establish a colony, are we simply repeating the mistakes of the past? The Martian story serves as a stark warning. A planet that once had the potential to support life but failed to maintain those conditions offers us a glimpse into the future of Earth. Should we continue down the path of environmental degradation and unchecked technological growth? The possibility of life on Mars raises an uncomfortable truth that even in a world as vast and seemingly infinite as the universe, survival may not be guaranteed for any civilization, including our own. The more we learn about Mars, the more it becomes clear that our existence as a species is far from secure. Just as Mars had the potential to sustain life, but eventually became inhospitable, Earth too could face a similar fate if we aren't careful. The story of Mars is one of cosmic fragility, warning about how easily a planet can lose the delicate balance that allows life to thrive. As we seek answers about whether life ever existed on Mars, we are simultaneously forced to confront the reality that life on Earth is not permanent, whether it's from climate change, nuclear conflict, or the development of new technologies that outpace our ability to control them. Humanity faces existential risks every day. This brings us to a crucial point. The discovery of ancient life on Mars or any other planet would not only teach us about the nature of life in the universe, but it would also force us to reconsider our own future. It might reveal that life is far more common than we think, which raises the question, why has intelligent life capable of interstellar communication and exploration not emerged elsewhere? This is where the concept of the Great Filter becomes especially relevant. If life can arise on planets like Mars, yet we still don't see evidence of advanced civilizations, perhaps the Great Filter lies ahead of us, somewhere in our future. The discovery of life on Mars would suggest that, while life might be abundant, the rise of intelligent, technologically advanced civilizations might be extraordinarily rare if the Great Filter is ahead of us. It implies that humanity could still face challenges so daunting that most civilizations never survive them. Could the most difficult part of our journey be ahead? If so, we must take it seriously and consider the steps necessary to ensure our survival. The search for life on Mars is not just about discovering something new about another planet. It's about understanding the fragility of life itself and how, like Mars, we might one day face a similar fate. Ultimately, the question of whether life ever existed on Mars, or whether it could exist again, is more than just an academic curiosity. It's a fundamental question about the survival of life itself, about whether the conditions necessary for life to flourish are common or rare in the cosmos. The answer could tell us a great deal not only about Mars, but also about our place in the universe, and more critically, about our future. If life once existed on Mars, it would imply that life is not as rare as we once believed. It would suggest that the universe might be filled with planets capable of supporting life, waiting to be discovered. However, the Martian story also serves as a cautionary tale. The planet that once had the potential to support life became inhospitable, and its transformation into the barren world we see today could offer a glimpse into Earth's future. Our planet, too, faces a delicate balance, one that could easily tip into an uninhabitable state. If we continue to push the limits of our environment, the discovery of ancient life on Mars would force us to confront the uncomfortable reality that the survival of life on Earth is not guaranteed. It would remind us that the fate of our planet is not sealed, and that we must take responsibility for its future. as we await further confirmation of the potential for life on Mars. We are reminded that the universe is full of mysteries waiting to be uncovered. But perhaps the greatest mystery of all is not whether life exists elsewhere, but whether we, as a species, can avoid the same fate that befell Mars: the search for life beyond. Earth is not just about finding something new, it's about learning how to preserve and protect life in the universe, starting with our own.